Hi, I'm Praska Sharma, Solution Engineer at Prove AI. In this walkthrough, I'll show you how to stand up a Gen AI observability pipeline using Prove AI version 0.1. We'll walk through an end-to-end setup that captures request level signals from real Gen AI workloads, turns them into structured metrics, and makes latency and token behavior visible across the system. I'll also show where the Prove AI dashboard fits as an optional analysis layer once the data plane is in place. Here's what that looks like in practice. You'll deploy a Gen AI observability pipeline in your own environment and watch how real requests flow through it. As those requests execute, we extract structural signals that can be analyzed over time without requiring deep custom logic in every service. The goal is to work with real traffic and real behavior, so you can decide whether this model of observability fits how your team builds and operates. Now, I'm going to switch over to the Prove AI GitHub repository to show you exactly what version 0.1 includes. Prove AI version 0.1 is a configured distribution of OpenTelemetry and Prometheus. It runs as Docker containers on infrastructure you control and acts as your Gen AI observability data plane. What you're looking at here is the entire data plane. There's no hidden control plane, no hosted collector, and no proprietary format. You retain ownership of your telemetry, define retention policies, and decide how metrics are queried or visualized. Version 0.1 is about getting the data model right first. Next, let's walk through the actual architecture that you'll be deploying. Here's the high-level flow. Your applications and inference services emit OpenTelemetry traces. Those traces are received by the OpenTelemetry collector included in this distribution. The collector is pre-configured with authentication, processors tuned for Gen AI workloads, and a trace to metrics pipeline. Prometheus scrapes the derived metrics, and Victoria Metrics stores them with long-term retention. The key idea here is that metrics are derived from traces and not emitted independently. That's what preserves context without duplicating instrumentation across layers. Now, I'll switch to the terminal and show you how to bring this up locally. Deployment is intentionally straightforward. Before you begin, make sure Docker Desktop is running on your machine. I'm currently in the Prove AI Observability Pipeline repository that I've cloned from the Prove AI GitHub. This starts as a clean environment. There's no config changes and no credentials set up yet. By default, it'll use the API key credential, or you can enable basic auth if you would like the option. The first thing I'm going to do is bring up the full stack using Docker Compose. This starts the OpenTelemetry collector, Prometheus, and Victoria metrics together as a single data plane. This takes a moment the first time because the images are being built locally. Once this finishes, my entire observability pipeline is running on my machine. Before sending any traffic, I want to make sure that everything actually came up cleanly. What I'm looking for here is that all of the services are running and healthy, that there's no crash loops and no failed containers. Next, I'll sanity check the OpenTelemetry collector directly. A healthy response here tells me that the collector is live and ready to ingest traces. At this point, the pipeline itself is up. Now the important question is whether it actually does what it claims to do. To validate the pipeline end to end, I'm going to send a single test trace. This doesn't require an application. I'm just going to emit one span by hand. That span just went through the same path as real production traffic would. It hit Envoy, was authenticated, processed by the OpenTelemetry collector, and passed through the trace to metrics pipeline. The key thing I want to show is that I didn't emit any traces myself. They should appear automatically as a result of that trace. I'll query Prometheus directly to confirm that. If everything is working, this returns a non-empty result. That metric only exists because the trace arrived. This is the core idea behind version 0.1. Traces are the source of truth, and metrics are derived from them automatically with full context preserved. Once you see this working, the pipeline is ready to handle real Gen AI traffic. Prove AI version 0.1 is designed to integrate cleanly with inference servers. The pattern is consistent. The inference server exposes metrics, Prometheus scrapes them, and those metrics align with upstream trace context. In version 0.1, vLLM is the primary supported example, but the same model applies to other runtimes. Now that the data plane is in place, I'll switch to the Prove AI dashboard to show how teams typically analyze these signals. Once your data plane is stable, you can optionally enable the Prove AI dashboard. It provides a Gen AI specific, resolution-focused view of the metrics that you already own. Think of it as an analysis layer and not a data sink and not a requirement. Prove AI version 0.1 is designed as a foundation. New inference runtimes, connectors, and best practices all plug into the same pipeline. As you add things like Ollama or custom on-prem models, the underlying architecture stays stable. That stability is what makes it possible to extend the system without reworking your observability stack. Thank you.